Welcome to Chapter 11, Section 3, Part B. We are now going to be describing mechanical waves. So, what we're going to do in this section is you're going to learn how to interpret waveforms of transverse and longitudinal waves. So we're going to have to learn what these three words here mean. So when we talk about mechanical waves now, we can talk about two different types. There are transverse waves and longitudinal waves. So first we're going to look at transverse waves. Transverse waves are waves that travel perpendicular to the particle's motion. So what that means is, like on the previous video, we talked about how this particle will travel this direction, right, and then back up. This one goes in this direction, but they're all traveling in this up and down direction, right? But the wave itself goes in this direction. So if we look at those, right, we can draw that line up here and we get a perpendicular line. So we've got the velocity of the wave here and we've got the particle motion down here. They are perpendicular. Any wave that is like that is a transverse wave. So this picture here now, this is called a waveform, right? Form kind of means how something looks. So a waveform is just a picture of a transverse wave as it would move through a medium. Our next kind of wave is a longitudinal wave. And a longitudinal wave occurs when particles vibrate parallel to the direction of the wave's motion. Okay, so these particles are moving back and forth like this, and the wave is moving in the same direction. So you can see that this line and this line, they are parallel. When we have this kind of wave, there's two parts to the longitudinal wave. There's the compression, where the particles are closer together, and the rarefaction, I'm going to say that again, rarefaction, where the particles are further apart. So here it's labeled for you. Here there's a lot of space in between our different particles, and so that is the rarefaction area. And here all the particles are really close together, and this is a compression area. So remember, what's happening is these particles, they're going back and forth, okay? And if this arrow represents the distance that one particle travels, like if this particle travels that distance, this is going to end up being the amplitude of our wave, okay? So when we have longitudinal waves, we can also have waveforms for the longitudinal wave. Okay, so what we do is we translate it essentially into what looks like a transverse wave. But in this one, what you're seeing actually is that the parts of the graph that are positive correspond to the parts that are more dense, right? So see here it says density. So here at the compression, it's more dense, right? And so we end up with our graph above the area, the zero line, right? But here we have our rarefaction here, where it's less dense, and that's going to correspond to our low parts of the wave, the trough, okay? And so then you end up with that repeating, okay? However, the height that this is remember, this particle is traveling back and forth, and that distance corresponds to our amplitude, okay? So we have density here and amplitude. So here's another example too, connecting our two things. If you have a slinky, this is called a slinky. It's that little like metal coiled thing that you play with. It can provide a really good example. So if you've attached it to the wall here and you move your hand back and forth, you create a longitudinal wave. Okay, and here if you shake it up and down, you end up with a transverse wave. In both cases, the distances, right, between two similar points. So here it's the rarefaction and the rarefaction. Here's the trough and the trough. That gives you the wavelength. And don't confuse this on a transverse wave with how far, here they're showing you how far a particle will move, and that is the amplitude. So let's take a closer look at describing our waves graphically, okay? So remember, we've talked about amplitude before, and remember that a wave is measured based on its displacement from equilibrium. And equilibrium is that center point. So the two things we'll talk about here with this specifically is amplitude, which is the maximum distance from the equilibrium point, and wavelength. Wavelength is the distance of the wave from peak to peak. So let's look at a picture of what that is. Okay, so here we have a transverse wave. Okay, and these two lowest points are called the trough, and these two highest points are called the crest. The distance from the equilibrium point to the crest or the trough, they should be the same, is your amplitude. The distance from trough to trough or crest to crest, and I should add that sometimes this is called the peak instead of the crest, so there's two words for that. Okay, the distance between those is the wavelength. So I just want to double clarify on this, okay? This top waveform here, this can represent either a transverse wave or a longitudinal wave, okay? So in a transverse wave, what it's showing, the amplitude shows exactly how far it actually travels, okay? So if we have transverse, okay, the amplitude shows the distance traveled. Okay, and that's the distance traveled perpendicular to the wave motion, or to the wave's velocity. Okay, now that same thing, if we are instead using it to represent a longitudinal wave, okay, we show the amplitude going in this direction, but what that represents, okay, is the distance here the particle travels from equilibrium. So it goes that far in that direction, right? And then we see it comes down here, and that's showing how far it goes in this direction here. So this particle will travel that distance. And that distance then will be equal to our amplitude. Don't get that mixed up with on a longitudinal wave where you have from, again, peak to peak or crest to crest, which is the compression, all the way to this other compression here, that is the wavelength. And I've kind of written over that. So you've got two differences that we're measuring parallel. Okay, one is the amplitude, how far one particle travels, and the wavelength, which is just the distance between the compression and the compression. Okay, please let me know if you have any questions, and I will see you guys in class.